Hello, today we're going to look at data structures and string handling. This is part of your Unit 4 Assignment 1. Some theory to help you produce your notes for the assignment and also to get you to do some practical coding as well to demonstrate a use of coding to show data structure and string handling. So to kick off with, a data structure is a programming technique used to collect and organise data items in a formal structure, which helps the data to be processed efficiently. Although the availability of certain data structures does vary between different programming languages, many are very common. These common data structures include strings, arrays, both one-dimensional and two-dimensional arrays, stacks, queues, records. Sometimes it is possible to program more efficiently through the selection and use of specific data structures, especially when this is combined with iteration control structures or using loops. Software developers become familiar with different data structures as they learn about different programming languages. Here are some of the most common data structures. So we're going to start with string, or text as it's sometimes called. String or text is a data structure which is used to store a collection of characters, with one character minimally requiring 1 byte of RAM. Strings may be a fixed length, for example, only containing a certain amount of characters, such as 10 characters max. Alternatively, they can use a special terminator character to mark their end. You can see an example on the left. After the word Venus, there's a hashtag character, which is used as a terminator character to mark the end of that string. This may mean that a string requires an additional character to be included, but it then allows them to have flexible lengths. An individual character in a string can be accessed by using its positional index. For example, on the left, you can see a string about planets. You can see the planet Venus has got various positions in place. Now, it's key to note that the first position, the uppercase V, the first letter, starts as position 0. So computers start counting from 0. So position 0 on that string, that planet string there, is V, uppercase V. So planet 2 would return lowercase n in that planet. So planet 2 would return lowercase n because it's the Venus is the planet and position 2 of Venus has the letter n. Okay. Some languages use a static one-dimensional array of characters to simulate a string rather than using a specific string data type. However, their use is very similar. Strings are commonly used to store simple text entered by the user, such as a username. Strings may also be used to enter more complex text for processing, such as the content of an email, instant message, or a tweet. The term substring is used to describe a part of a larger string. So, for example, ear would be part of a substring of the planet Earth. Then would be a substring of Venus, as you can see in the example on the screen on the left. Arrays, so one-dimensional arrays first of all. Traditionally, this is a static data structure, which means that it has a fixed data size. However, modern programming languages are generally more flexible and allow an array to be resized. Typically, an array can only store one type of data. Any type of data, such as integers, characters, or booleans, is acceptable. If you want to store, for example, the results of points gained by a team across 7 football matches, as you can see in the top example on the right-hand side of the screen, then that's how you'd store it there. So again, you start at 0, position 0. The first match, the team won, so they got 3 points. The next match, they got 1 point. Third match, position 2, they got 3 points. They won again. Then the next match, they drew. The fourth match, they drew, which is position 3. They got 1 point. They then lost the next 2 matches, so positions 4 and 5, 0 points. And then the 7th match, the final match, they drew, so they got a point there, and that's at position 6. So you can see that example there. So it does appear similar to a string. In fact, you can think of a string as an array of characters. As with a string, it's possible to access individual elements or items in an array. So in the example you can see there, result 4 would give you a return of 0 because position 4, or match 5 as we know it, position 4 has 0 entered in that particular one-dimensional array. Two-dimensional arrays a two-dimensional array is similar to a one-dimensional array, but it can store multiple rows of data. So, for example, what we've got now is the scores, the points scored by two teams in the bottom right example you can see on the screen. So you do that over subsequent weeks. It's done over 7 matches. The results of 2 teams there. So the first team is in row 0, position 0. The second team's results is in row 1, as you can see numbered on the left-hand side. So it is, again, as before, in a two-dimensional array, it's possible to access individual elements or items in an array using both indices. For example, result 4 would give you a 0 and 0 for both teams. Result 5 would give you a value of 0 and 3, because the first team got 0 points in match stored in 5. The second team won the match and they scored 3 points. So position 5-1 would give you a return value of 3. Position 6-0 would give you a return value of 1, because it's result 6, row 0 would give you a value of 1. The order, the actual order of indices, may vary between different programming languages. The general rule is that the element access order will reflect the declaration order of the array. For example, you could not access an element in score 0, 1, as either the indices do not reflect the declaration order of the array. It is possible to use a higher order of dimensions. For example, a 3-dimensional array could be used to store 21 results from 3 different teams, as an example. Arrays can be split and joined. In some languages, this is called exploding arrays and imploding arrays. In languages where strings are stored as arrays of characters, the extraction of substrings and concatenation, concatenation means joining things together, of different strings, are practical uses of these types of operation. We'll go into that a little bit more in string handling. Next, we're going to look at stacks. So the first stack we're going to look at is known as a LIFO data structure. LIFO stands for last in, first out, and describes how data is treated in some data structures. It means that the last item of data pushed onto the stack is also the first item of data that is pulled back off. So a LIFO data structure has 2 basic operations, push and pull, sometimes known as push and pop. Stacks are a vital part of any computer platform's operating system, as they are a common tool for a programmer to use when developing solutions. Stacks are conceptually viewed vertically, so one on top of the other. So if you look at the example on the left-hand side of the screen now, you can see that we have a stack here on the left-hand side, where C is at the top of the stack. So when you're pulling that job or that data or whatever it is off, C comes off the stack first, and then B goes to the top of the stack. A new item is pushed on, so item D is pushed onto the stack, and if that's pulled, the next item to be pulled off the stack would be item D, because that's the top of the stack. Last in, first out. You can see some stack operation code if you look at page 239 of the textbook. There's some C# code that you can enter in, and you can see stacks in operation with coding. Unlike an array, where elements may be accessed in any order, a stack can only be accessed in last in, first out manner, LIFO. This can be particularly useful when processing recursive algorithms. Now, a recursive algorithm is a piece of programming code that executes itself repeatedly until it reaches an end condition where the calculated result is returned. Stacks are often included in programming languages libraries, complete with necessary methods to process them. On the right-hand side, you can see an example of a queue. Queue uses the first in, first out, FIFO structure. First in, first out. It has 2 basic operations. It adds to the tail of a queue. This is known as on queue, or it will remove from the head of the queue or the front of the queue, which is known as dequeue. Only data at the head of the queue can be accessed and removed. So that's what first in, first out means. The first item of data is added is also the first item of data that may be removed. Like stacks, queues are a vital part of any computer platform's operating system. For example, you're probably familiar with printer queues. So the first job sent to a printer queue will be the first job out of a printer queue, coming out of a printer. For a programmer, queues are an excellent way of managing task processing. To get a concept of a queue, you can see the diagram on the right hand side. Okay, you have the head of the queue on the left, the tail of the queue on the right. A is job A or process A or data A to come off the queue. That comes off first. When a new item is added, it's added to the tail of the queue on the right hand side. And then at the bottom part of that diagram, you can see B, job B is now, or print job B is now the head of the queue. That will be the first job processed because that was the first job in that order. There is also a demonstration of code. So that concept you can see there, you can demonstrate it using C# code using the example that is on page 241 of the textbook. Now we're going to look at string handling. Now, although strings are simply a collection of characters, there may still be a need to process characters and process strings. This task is commonly known by programmers as string handling. Programmers often need to perform certain operations on strings, and most high-level languages have specialist library functions to help. We're going to look at some common tasks using the C# code, look at some practical examples using C# code showing their implementation of string handling. Similar string functions exist in other programming languages. So first of all, finding the length of a string in characters. As in the top part of the example you can see on screen now, the length property of the month string object is used to access the string's number of characters. In this example, the string is the word January. So the result you get from that, the length of that string month January, would be 7, because there are 7 characters in that string or that word January. Examining or extracting single characters. So in the diagram you can see at the bottom, the example code you can see on the bottom of the screen. The output will be character 3 of January is U. This is because U is the character in position 3. The string starts with the uppercase J in position 0. So remember, positions start at 0, not at 1. So we'd say the first character in January is the uppercase J. In computing terms, it's position 0, uppercase J. Therefore, position 1 is A, position 2 is N, and position 3 is the lowercase u. So that code you can see there would return lowercase u as the example. Extracting a substring. So in the example you can see in the top of the screen, extracting a substring, the output of that code would be UA. This is output because we start extracting at position 3, which is letter U. So int start pos equals 3 means we start at position 3, which is the letter U. Just remember we've got 0, 1, 2 and 3. So the fourth letter, U, is position 3. And it's asking, we want to extract the next 2 characters, including the first one. So where it says int how many, we're extracting 2 characters there, starting at position 3. So it would extract U, and then the next character would be A. That's the 2 characters it would extract, U and A. Concatenating, which means joining together 2 strings in the form of a new string. You can see that example code at the bottom of your screen now. Concatenation is the process of joining things together. In programming, it's used to describe the process of joining shorter strings to form longer ones. So in the example you can see on the screen there, that's going to join the string January with the second string that says has 31 days. So we're going to join those 2 strings, January and has 31 days. The output will give you the joined string is January has 31 days. So that console write line would say joined string is 0, 0 is combined, combined is month plus saying, month is January, saying is 31, so joined string is January has 31 days would be your output. This is output because we use the plus operator to join the 2 strings together. There are other techniques available in C#, but the plus string is probably the easiest to use. So again, it's worth trying that code out using the online platform for C#. I'll show you at the end of the presentation where you can go online to key in some C# code and you can try this code out to see it working. Okay, so your task this week is I will email you a Word PDF document worksheet 4.8. It contains some code for you to key in. I want you to go to the link there. You can see codechef.com/IDE. It works quite effectively. It allows you to code in different languages, compile it and run the code. It will default to C++. You can change it to C#. The worksheet 4.8 has got some example code for C++ and C#, so you can use either. If you want to use the examples in the textbook, then use C# as your example there. Key in the code from the task sheet, and then you can see how queues and stack work by using coding in C#. Screenshot evidence of you entering code, running the program, compiling and running it. Screenshot evidence. Look at the notes in this slideshow. Look at the notes on textbook pages 237 to 246. Put those notes together. Add that to your Unit 4 Assignment 1. So that's your task for this week. So I will email you the worksheet you can see on screen now, worksheet 4.8. Go to the codechef.com /IDE website. Enter the code from the worksheet using C++ or C#. You can see how queues and stack work via coding. Screenshot your examples. Use some additional notes from this slideshow and from pages 237 to 246 of the textbook. I'll also send you those extract pages as well to build up your Unit 4 Assignment 1.